Okay, so when we're setting up our histogram, we would, across the bottom, we would want to have the midpoint there. So if we start at, say, 670 to 680, then I would just write all of those by tens. The rectangle would be in between these various numbers. So it'd be centered at the midpoint. So between 670 and 680, it'd be centered at 675. Okay. And then going up, we want to look at our numbers here, and it looks like, well, it looks like I can count pretty accurately here. Highest being 11. So 3, 6, 9, 12. Okay, and then I would just follow in what the frequencies are. So 207. And then 7. Okay, so that would be what our histogram looks like. Now, if you want to see an electronic version of this, there you go. There's the same picture. Mine's pretty close. Anyway, so you can kind of see the difference there. Now, I do want to point out one little thing. Our choice of class width was something we made up. There are good reasons why you want to have certain class widths or not. But if you go more in detail and you make your class width smaller, you do get more. You do get a chance to see other patterns. One graph is not necessarily better than the other. Typically, I'll try to tell you ahead of time how many rectangles or how wide I want the graph to be to give you credit. But there is more than one way to do this. And if we use those other widths, we do get a similar feel between the graphs. It does there, but there is a slight distinction, but it does have a similar. I mean, there are similarities between it. Okay, so there are some guidelines to determine how wide we need to make the intervals. Typically, we find our largest number minus our smallest and divided by how many rectangles we'd like. 10 is a pretty good number. Not necessarily a requirement, but typically if you take it and divide by 10, that'll give you a good width that you can go with. But it's not required. Okay, so the next topic we want to address is what's called a stem and leaf plot. Stem and leaf plot, each data value gets put in the graph. Well, okay, we'll kind of get to how it's constructed. So one idea for stem and leaf plot is if I had a number 302, then if my stem was the first two digits, then I would write a 30, and then I'd want a line, and then there'd be a 2 after it. Would be another way to represent. So anything in the 300s to that point. If the next number up was 310, then it'd be 31 with that same line too, and then any data that, so say I had 310 and 313, then I would have a 3-1 and then a 3 afterwards. So the 2 and the 3, so the 2 would represent, I'm sorry, not a 2, the 0 would represent 310 and the 3 would represent 313. It's kind of how we're going to look at doing this. So the steps are, this is straight out of the textbook. Look at the leftmost and the rightmost digit. The leftmost is your stem, the rightmost is your leaf. So we're going to go through and do that stem and leaf plot to this data here. So I want to look at, this is the unemployment rate, percentages per state. So as we're looking at this, we want to look at what our largest and smallest is. And it looks like the numbers range from, okay, so as we're looking over the data, it looks like the smallest, I don't see anything smaller than 2.8, and 8.5 would be the largest. So let me get my little graph here. Okay, so I'd want to set it up so that 2, 3, 4, 5, 6, 7, and 8. So the first digit, so we're going to say that 2.8 would translate to 2.8. This is what's called a key. Tells everyone how to read this. So I want to go through my numbers and collect up all the digits related to that percent. So if I see anything else with the 2 in it, I want to put that in there. Let's see. So I want to see if, let's see, 3 would be the next one. So do I see any 3.1s? Looking through the data here. So we got 3.2 and 3.2. Okay. So each observation gets a number. So I'm going to go through and I'm going to collect up all of these numbers. So let me pause this. Okay. Actually, we're going to just collect them up. So starting with Alabama's 4.7, 6.8, 4.8. Arkansas is 5.0. So I'm just going to write them down in the order I see them. And I'm going to come back and we'll reorganize it in a second. Let's see. So I got 6.9 there. So Colorado's 5.1. So I'm just going to collect up all these numbers. Okay, so here's what I've got so far, just going through the raw data. And then what we can do is we can go back through and put them in order, which is what a true stem and leaf plot has, is it has the order to it. Let's see, so I got what, 3 2s, so 2 2 2, and then I got a 3, then I have 3 8s, 8 8 8, and then 9. So I'm going to rearrange these from highest to, sorry, lowest to highest. Okay, so now when I rearrange this, now I've got it in this one right here in proper order. Now the nice thing about this is then eventually we're going to learn about the average, we're going to learn about variance and standard deviation, so we're going to learn about some more ways to describe data. But if you tilt it on its side, you can kind of sketch in a curve, and even though you don't have it's just a picture, you get a general sense as to whether the data is one of several different types of graphs that we're going to eventually look at. So anyways, this is called a stem and leaf plot. Okay, the next graphical display we're going to look at is called a dot plot. This is a nice, it's a nice one compared to the others. There's less work involved, I think, sometimes in creating them. What we're going to do is we're going to set it up as though we're doing a histogram, where we're going to look at the classes, we're going to look at the observations. In this case, we go from 0 to 5, so that's not that bad to set it up. So 0, 1, 2, 3, 4, and 5. And of course, we want to have some sort of indicator going up. So what the nice part here with this is, as we see an observation, we just put a dot on top of that number, and we just need to make sure our dots are uniform in their heights. So 3 would get a dot, 4 would get a dot, 1, back to 3 again, this time at 2, this at 0, then at 2, then at 1, 3, and 3, so on and so forth. So we just kind of keep track of how many dots show up in each part of the graph. So I'm going to kind of pause this and kind of speed up. Okay, so there's what our dot plot looks like after we've gone through all the data. And the nice thing is, it was similar to a histogram or similar to some of the other graphs we've seen. We can connect it, kind of think of it as a general, if you draw lines, a smooth curve on top of that, that sort of describes generally what the data is looking like. And so now that we've known about several displays, let's talk a little bit about how to describe them. Okay, so I'm going to do this verbally first, and then I'll show you some pictures of this. So a uniform distribution is when each value that could show up with a variable has an equal likelihood of showing up. So it's fairly even, looks kind of like a rectangle. A bell-shaped distribution is what we normally consider to be a normal curve or symmetrical curve or a bell-shaped curve. There's a big hump in the middle, and off to the side there's some smaller, what we call tails. And then skewed right and skewed left. This is when data is predominantly on one side of the graph versus the other. And the strange thing is, when we talk about skewed right or skewed left, the left or right word corresponds to the tail in the graph, corresponds to where the data is not versus where it is. So let me give you some visual pictures here so you can kind of see the difference between what I'm talking about. So this would be a uniform graph, the first one bell-shaped. Skewed right, notice the right side is where the data is missing. So we say it's skewed right or positively skewed. It's another phrase you might see. This would be skewed left since there's more data missing at the beginning. So this would also be negatively skewed. It's another way to describe that. Okay, so now that we have those ideas, those words, let me introduce another concept called how do we describe graphs, now that we've seen a couple of these. So a lot of times in statistics, they're going to ask you to describe a particular graph. And at this point, we've seen two different types of graphs. We've seen categorical and we've seen numerical. So with categorical, those are the bar graphs, double bar graphs, and the circle graphs, the pie graphs. Those are all that fit under that category. With those kind of graphs, there's all we can really do is we can talk about the most versus the least observation. Okay. With numerical, okay, so far we've seen histogram, we've seen stem and leaf, and we've seen dot plot. Okay, there's a lot more we can describe with numerical data. We can talk about its center, which we're going to get to in a future section here. We can talk about anything unusual. We can talk about its shape and its spread. Now, shape, we just learned the words for it. We just learned words like uniform, bell-shaped, and then skewed, one way or the other. So when given data and that we're describing, we now can fill in one of the four words. We'll eventually learn how to identify the others. Now, interestingly, nice little acronym to help remember this. Whenever you're describing numerical data, remember to cuss at it. Identify its center, unusual shape, and spread is a nice, easy way to remember what things